One of the most efficient engine designs created is the Stirling engine, a type of closed-circuit heat engine that exchanges thermal energy for mechanical work. The Stirling engine was patented by Robert Stirling in 1816, although their use has been recorded from the late 16th century onward. The main components of this Stirling engine consist of a chamber with a hot and cold plate on either end, a displacer residing in the center of the chamber attached to a crankshaft. The crankshaft also has a flywheel to maintain inertia and a piston connected, which is also connected to a cylinder attached to the displacement chamber. As the displacer oscillates, it transfers motion to a crankshaft, causing it to rotate and move the piston. This motion is caused by a difference in temperature and volume. The bottom plate is placed on a hot or cold surface. For this demonstration, let's imagine the bottom plate is placed on something hot. As the bottom plate becomes hotter, it warms the air, expanding it, pushing the upper piston to move and turn the flywheel. The inertia of the flywheel causes the crankshaft to continue turning and pushes the displacer down, forcing the hot air to the top of the displacement chamber, where it cools, decreasing in volume and pulling the upper piston down again. While this is occurring, warm air is still building at the bottom of the displacement chamber and pushes the piston up again, causing the cycle to repeat. The crankshaft must affect the displacer and upper piston at the correct angles to assure the motion created fits a cycle. Note that when the displacer is at its highest point, the upper piston is halfway along the cylinder in an upward motion, and when the displacer is at its lowest point, the upper piston is halfway along the cylinder again, this time in a downward motion. These timings increase the efficiency of the engine. The mechanical energy created can be further harnessed by connecting a belt or gear to the crankshaft and directing it towards a motor or transformer to create electric current. Stirling engines are not commonly used as often as combustion and other types of engines. This is mainly because the power output of Stirling engines is affected through temperature change, making them slow and less than ideal candidates for applications that require a quick change in power output, such as a car accelerating. Stirling engines also become harder to design and create larger power outputs that are not currently as economical as technologies in place. Although small variation Stirling engines have been used for solar power extraction, like in the Maricopa solar plant, and use in silent submarines, they have yet to emerge with cost-effective designs and outputs that bring them outside of specialized roles.